There's this thing that physicists do is that they try to find ways to say that things that look different are actually aspects of the same thing viewed from different angles. It's this like really satisfying thing when you can say, oh, it looks like, that's two faces and a vase, but actually you're just looking at it in different ways, and actually they're the same picture, right?
Yes, novelists also find this very fulfilling work.
Right, exactly. So this is something that physicists are always trying to do. We're always trying to make things simpler. So we don't like it when there are lots and lots of different particles. We want there to be, one kind of particle doing different things, for example. So when it was discovered that, all these different elements are actually different arrangements of the same fundamental particles, that was amazing. That was mind-blowing. The fact that hydrogen and carbon are actually just different numbers of protons and neutrons and electrons, like awesome, right? That's great. So we want to be able to do that with other things too, right? So the idea that like, oh, we have all these different forces. No, they're really the same force. They just look different because we're in this weird low energy perspective.
Oh.
That's what we really want to do. And so that's what grand unified theories are all about, is trying to say, no, we don't have all these different forces. Actually, we have one force and something happened to make it look like they're different forces. Something changed in the early universe that broke this symmetry that was all set up. Everything was all super like nicely symmetric and beautiful and perfect, and it broke at some point in the early universe, and that's why now we have all these different things.
That's why we're here, because something broke.
Exactly. And so we've got good theories to do that for the fundamental forces of particle physics, strong, weak, and electromagnetic. We haven't yet been able to do that with gravity. We're still trying. So the reason I'm putting gravity aside is because, so this is where we get into weird namings again. If you can unify the strong, weak, and electromagnetic forces, you have a grand unified theory. But if you can unify those with gravity, you have a theory of everything.
Oh.
So that's even better. That's even cooler.
Because that would explain literally everything.
Yeah, if you can get gravity to work together with the other forces, then you've solved it, right? And that's the theory of everything.
That was a clip from The Universe, a new limited series podcast from Crash Course where Dr. Katie Mack, a theoretical astrophysicist, walks me through the entire history of the universe, including the parts that haven't been written yet. It's available now both on the Crash Course YouTube channel and wherever you get your podcasts.